So section 2.2, we're going to look at the function notation and then look at the equations that I was talking about in the first section. So function notation is read f of x, and it's just another way of saying y. And what it really means is that the equation is a function of x. So f of x would be the y term, x is still x, it's the independent variable, or that's our domain. And you can use any letters to identify different functions. Some are very specific. So if you're taking a business course and you want to talk about cost functions and revenue functions and profit functions, you're going to use C of x for cost and R of x for revenue and P of x for profit, because it's just easy to distinguish which one is which. So again, these are all representative no matter what variable you use, except for you can't use x of x. But the rest, you can. They're all going to represent your y term. So for our example, we have y equals 2x plus 4, and that's the standard form for the equation of a line. And then we have it rewritten as f of x equals 2x plus 4. These are exactly the same equations. It's just one is written in function notation and the other one is using the y. So if we have two of the points, and I just have the x and y intercepts here. So 0, 4 and negative 2, 0. That's where these 2 points on the graph. They're ordered pairs. So the point xy can be written as x comma f of x instead of xy. This notation in this form is not as nice to use, but it is nice when, again, you're distinguishing between different functions. It's also nice when you want to evaluate the function at a specific point. So if I have f of 10, that means I'm going to find the function that's the f of x function, and wherever I see an x, I'm going to plug in 10. So f of x was 2x plus 4, so we have 2 times 10 plus 4, and it's 24. So instead of writing take the function and evaluate it when x is equal to 10, this little shortcut gets right to the point. Find the function, plug in 10 for x. So we have some functions here. H of x is x squared minus 5, f of x is 2x plus 4, and q of x is x squared plus 3x. And I want to evaluate it. So q of 3. So here's my q function. So I have 3 squared plus 3 times 3. So that would give me 9 plus 9 is 18. So q of 3 is equal to 18. F of negative 5. Here's my f of x function. So I have 2 times negative 5 plus 4. So negative 10 plus 4 gives me a negative 6. H of negative 2. So here's my h of x function. So I have negative 2 squared minus 5. So negative 2 squared is 4. 4 minus 5 gives me a negative 1. Q of 0. Okay, back to my q function. 0 squared plus 3 times 0. I just have 0. And then lastly, f of negative 2. So 2 times negative 2 is negative 4 plus 4. I get a 0. Now we have the equations. And I want to know, what do I need to restrict from my domain to make sure it's still a function? There's only 2 things that we have to worry about. One is we are not allowed to have division by 0. So if I have a fraction form, a rational, I have to look at that denominator and see what makes it 0. And then secondly, we're not allowed to have a negative inside a square root. So when I look at that one, I want to make sure that I don't have these imaginary or complex numbers. So when I have a radical, that's the second part I'm going to look at. What do I have to do to make sure that when you solve for that variable, you don't get a negative inside of there? We're going to go through and look at the domain for each of these, right? We want to figure out the domain for each of these. And these are the only two things I'm going to worry about. If I don't have a fraction or a rational and I don't have a square root, my domain is going to be all real numbers because we're just looking at polynomials. So here, the first one, there's no rational and there's no square root, so it's all real numbers. Number two, I have another polynomial. So again, it's just all real numbers. Number three, now I have a square root. So I'm worried about case number two. We're not allowed to have negative values inside of there. So 2n minus 8 has to be greater than or equal to 0. I can take the square root of 0. I just can't take the square root of a negative number. So we add 8 to both sides and we get 2n has to be greater than or equal to 8. Divide by 2. We get n is greater than or equal to 4. So we can leave our domain like that, or we talked about interval notation. I would put a hard bracket by 4 because it's included, and then it goes to infinity, and always a parenthesis near infinity. So there's my domain, and again, these are both fine for you to express the answers. Number 4, I'm worried about the first case. We're not allowed to have division by 0. So 2x plus 4, what makes that 0? I'd subtract 4 from both sides and then divide by 2. So negative 2. If this was negative 2, I'd have division by 0. So my domain, the easiest way to write that is x cannot equal negative 2. It can equal absolutely anything else except for negative 2. All right, number 5, here's my variable. It's an exponent. I can take a positive and negative exponent. I can take the exponent of anything I want. There is no division by 0. There is no square root. So therefore, I'm at all real numbers. Number 6, we have fraction again. So I don't want to have a 0 in my denominator, so I need to know when c squared plus 3c is equal to 0, because that's what I have to restrict. So I'm going to factor out a c, and I get c times c plus 3 equals 0. Set each of those equal to 0. So my solutions are 0 and negative 3. So my domain is c cannot equal 0 or a negative 3. In interval notation, it would go from negative infinity, to negative 3, and then we'd have to skip over that, and then negative 3 to 0, then we have to skip over that, and then 0 to positive infinity. So that's a lot longer to write out, but that's what it looks like in interval notation. Number 7, the denominator is w squared plus 1. So this one is an all real number. No matter what number you plug in here, you're squaring it, so it's going to become positive, and then you're adding 1 to it. So your domain is all real numbers. And then number 8, again, I have another polynomial. No division by 0, no radicals. So it's again an all real number.